Hi students, welcome to Science Extension and Module 3, the Data, Evidence and Decisions. This is video number 9. We're going to put together the two concepts of accuracy and precision in practical investigations. So we need to apply appropriate performance measures to statistical analysis of quantitative data sets obtained from conducting a relevant practical investigation. And we're going to this time look at both accuracy and precision. So NISA describes accuracy as an emphasis on exactness. And I guess in some ways we can parallel this exactness into our concept of validity. That is, how close a particular measurement is to or deviates from the true value. We talked about this a little bit when we were talking about errors. And now we want to try and think about how we can go about minimizing those particular errors, or at least trying to get as close as we possibly can to the true value. Acceptable levels of measurement accuracy depend on their intended uses, and there are some things that limit how accurate we can be. In simple terms, we may be looking at our measuring devices and to what degree those measuring devices can actually measure. So we've talked, for example, about accuracy increasing from measuring volume in a beaker to maybe measuring volume in a measuring cylinder, and then perhaps measuring volume in a graduated pipette. Perhaps if we use a burette, we know we can get down to 0.1 of a mil nice and easily, and it gives us a good understanding of how accurately we can get those particular measures. Now, there's also some accepted values for certain types of constants, which are often ones that are included on some of the stage 6 data sheets. One of those, for example, is the mass of an electron. So the mass of an electron has an order of magnitude of 10 to the minus 31. So 9.10938,356 times 10 to the minus 31 kilos is the standard mass of an electron. This has very high accuracy. If you count up the number of significant figures in this number, you'll find that there are 9 significant figures. But that's a huge number of significant figures, and generally speaking, way beyond any of the measuring devices that we have available to us in a science laboratory. So unless there's a particular reason why we want this sort of level of accuracy, we may reduce this down to 2 significant figures and just write this number as 9.1 times 10 to the minus 31. Now, of course, we have talked in the past about what we might do if we continue to round different parts of calculations. We can tend to magnify errors over time. So these are often decisions that are going to need to be made on the basis of the type of experiment that you're intending to carry out, and then the types of calculations that you may perform with your data. Another example might be the charge on an electron. So if we have a value which we regard as our true value, the actual value that we would like to find, if we do an experiment that allows us to calculate the charge on an electron, then what we want to try and do is see if we can get something in our experiment as close to this true value as we possibly can. The degree of closeness, or the emphasis on exactness in terms of how close we are to this true value, is going to be affected by accuracy. So it's very, very important that we think about the most accurate way that we can measure all of the variables that we think are going to be important in our experiment. And simply put, accuracy can be improved through selection of the right piece of instrumentation to record particular measurements. And we've talked several times about the application of this in terms of something like volumes. In contrast to accuracy, precision is about emphasizing agreement, how close a series of values are to each other. So if accuracy is trying to get to a true value and therefore a valid score, precision is more about reliability. It's how consistently we can get the same sorts of scores. And one of the consequences of this is that there's 2 types of precision. There's measurement precision, and then there's instrument precision. So we'll quickly have a look at each of these 2 types. In measurement precision, we're talking about the extent to which repeated measures made under identical conditions agree with each other. So this is our link to reliability, where we talk about repetition with consistency. And so precision plays a little bit of a role in this particular area. It can describe the range of different values or the dispersion of values around the mean or the median. And so therefore we can get a bit of a sense of precision by looking at things like the range or the standard deviation to see how compressed those values are, or conversely how spread out they might be. So any of those measures of variance that we've talked about previously, range, variance, standard deviation, or standard error, can all be used to evaluate how precise your data is. By contrast, instrument precision refers to the error associated with the measuring instruments, and they can be either analog or digital. Generally speaking, digital devices are more and precise than analog devices, although sometimes the lack of precision isn't associated with the actual measuring device, and perhaps not even the fault of the operator. There can be chaotic systems that may have an impact on particular types of data that are coming through. And we've all had the experience around things like internet services, and sometimes they drop out for different reasons. So there can be external factors beyond your control that may be having an impact on particular types of devices that you may be using. And that's one of the reasons why we also are focused on this idea of reliability. We want to try and make sure that whatever conditions we can control them, and we do control them. But what we also want to do is try and make sure that when we're taking a series of measurements that we are repeating our experiments, we're making sure we're getting some consistency in our results. And of course, the type of experiment that we're doing is going to be directly affecting how precise we want those results to be. So if we're doing a titration, for example, we're going to have a much smaller margin for error than perhaps if we're measuring volumes in a measuring cylinder. So there's a really nice graphic that you can see that I guess identifies the difference between precision and accuracy board. If the goal is to hit the target, that is the center of the dartboard, then it's accurate and precise if all of our darts are all landing in about the same position, and that is the center of the target, the actual place we're aiming. If we are relatively accurate but not precise, then we might have a distribution of our darts all sitting somewhere around the center, but not close together. Alternatively, we might be precise without being accurate, which again means that we've got a smaller range, a small cluster of values that are all sitting close together but aren't actually on the center of the bullseye. So they're somewhere out, which means that they are precise. They're all very close together. And this is one of the things that often happens when we're carrying out experiments where we do have a problem between, say, the experimental and theoretical values. And if you think about some of the enthalpy of combustion problems that you may have had in chemistry, often what we find is some precision. We get some consistency of values, but they don't actually match the theoretical value, that true value. And that's partly because of the circumstances where, say, a lot of energy that's being generated in a reaction is not going to heating up the actual system, it's being lost to the surroundings. The last of these little boxes, of course, is no precision and no accuracy, which just basically means everything's all over the place. There doesn't seem to be a pattern, they're not close together, and they're not really distributed around the bullseye either. So this is a nice little graphic just to give you an idea of how we might go about contrasting accuracy and precision. So accuracy is how close we get to the true value, that is an emphasis on exactness, and precision is about consistency. It's about whether or not we can continue to hit all of those targets consistently, so that we're trying to have a small range, a lot of values in a small area. Thanks for watching.